Have you ever walked through a factory or warehouse and noticed a robot silently gliding across the floor like it owns the place? Without any human operator or remote control, it stops at intersections, avoids people and obstacles, and somehow always knows exactly where to go. That's not magic. That's cutting-edge automation at work. And today, we're diving into the fascinating world of AGVs and AMRs. These two robotic marvels are revolutionizing the way goods are moved inside factories, warehouses, and even hospitals. But what's the difference between them? How do they work? And what makes one smarter than the other? Let's know about them in today's video. Welcome back to Mr. Smart. Let's start by imagining a warehouse floor. There are racks of products, shelves of materials, and urgent orders waiting to be picked and packed. Traditionally, workers would use forklifts, carts, or trolleys. But now, robots handle that job efficiently and tirelessly. That's where AGVs and AMRs come in. AGV stands for Automated Guided Vehicle. Think of it as a robot on rails, but invisible rails. AGVs follow fixed paths, usually guided by magnetic strips, QR codes, wires embedded in the floor, or even optical tracks. Once they're set up, AGVs stick to these paths like a train on its track. But here's the catch. If someone leaves a box in their way, or if you change the layout of the warehouse, AGVs get confused, or worse, stuck. They don't think. They follow instructions. On the other hand, AMRs, or autonomous mobile robots, are like the smart younger siblings of AGVs. They don't need floor markings or preset paths. Instead, they build a map of their surroundings and make real-time decisions. If there's an obstacle, they go around it. If the environment changes, they adapt. In short, AMRs don't just move, they think while moving. So how exactly do these machines work? Let's peel back the layers and look inside. First, every AGV or AMR starts with a chassis, the physical frame. Wheels, motors, batteries, and control system. Many of them use differential drive systems, with two powered wheels that can rotate independently. This allows them to spin in place, take tight turns, and maneuver in narrow aisles. To move smoothly, the robot's controller constantly calculates motor speed and direction using PID controllers. It ensures that if the robot needs to travel straight, both wheels spin at the right speed. If it needs to curve, the inner wheel slows down, while the outer wheel speeds up. Precision motion, all through mathematics. Now let's talk guidance. AGVs, as we said, depend on external cues. If they follow magnetic tape, a set of magnetic sensors underneath constantly reads the strip's position. If they use QR codes or optical markers, cameras or photodiodes scan the floor and match each code to a preloaded map. These systems are simple, robust, and effective, but not flexible. If you want to change routes, you need to physically rearrange the layout or reprogram the path. AMRs, however, use something called SLAM, simultaneous localization and mapping. This is where things get truly mind-blowing. They use a combination of LiDAR sensors, 3D cameras, IMUs or inertial measurement units, and wheel encoders to map the environment in real time. The LiDAR scans the surroundings by firing laser pulses and measuring the time it takes for them to reflect back. These reflections create a detailed 2D or 3D map. The camera adds visual context, while the IMU detects motion and tilt, and wheel encoders tell the system how far the robot has traveled. All this data is fused together by powerful onboard processors, often running with our OS or robot operating system, and continuously update the robot's position and map. If a person walks into the scene, the robot pauses, recalculates its path, and navigates safely around them. No panic, no confusion, just smart decision-making. To stay connected with the outside world, both AGVs and AMRs rely on communication systems. They might talk to a central fleet user using Wi-Fi, Bluetooth, or industrial protocols like OPC-UA. This allows users to assign tasks, monitor battery levels, and track robot locations in real time. In industries, safety is a top priority. AGVs usually have bumper sensors and safety scanners. AMRs go even further. They have 360 degrees LiDAR coverage, 3D vision, and dynamic obstacle detection. If someone walks in front of them, they stop instantly. In regulated environments. Now, here's something fascinating. The line between AGV and AMR is slowly fading. Many modern AGVs now use elements of autonomy, while AMRs are becoming more affordable and accessible. The future is moving toward hybrid systems, robots that can follow instructions but still make smart decisions when needed. So, the next time you see a robot silently gliding across a factory floor, remember, it's not just rolling around. It's sensing, thinking, calculating, and navigating a world designed for humans. It's part of a smarter, safer, and more efficient future where machines do the heavy lifting, and humans focus on creativity and control. If this kind of tech excites you, be sure to hit that like button, subscribe for more deep dives into automation and robotics. Until next time, stay curious and keep watching how the future is being built, one robot at a time.